All right, so this is 8.7, Kramer's rule and determinant. So let's start with determinant. So what is determinant and etc. Things like that. Okay, share the desktop. All right, so 8.7 is determinant and Kramer's rule. So determinant and Kramer's rule. All right. So what is a determinant? And it's related to matrix. So what is a matrix? So a matrix is an array of numbers. Okay. So example of matrices is A is equal to 1, 5, -7, 2, 5, 6. This is an example of matrix. So basically it's an array of numbers. Or another example is 2, -3, 6, -5, 7, 2, 2, -8, 7. Now, can you tell me how many rows and how many columns does A have? Yes. So this is 2 rows and 3 columns. So we say that A is 2 by 3. So A 2 by 3. So I write it like this. A 2 by 3 is 2 rows, 3 columns. Right? So B is what? 3 rows, 3 columns? Okay. So that's why we write B as 3 by 3. So we read this not 3 times 3, but 3 by 3. Yeah? 2 by 3, 3 by 3. Okay. Now, what do you think a square matrix will be? So a square matrix. What is a square matrix? It's a matrix which has the same number of rows as right? 2 by 2, 3 by 3, 4 by 4, 5 by 5. They're all called square matrix. All right. So, for example, you can name them anything. C, just say 2 by 2. So let's just say this is 5, -7, 2, -6. This is a square matrix. D, which is 3 by 3, which is 7. 7, -3, 5, 0, 2, 6, -5, 3, 0. This is also a square matrix. This is 3 by 3. Yeah. Okay. So the next thing that we're going to do. Oh, by the way, did I put top here? Yes, I did. So determinant. What is determinant? So determinant determinant is a number associated with a square matrix. Yeah. So determinant is a number associated with a square matrix. Yeah. So now let's write down the determinant for 2 by 2 only with a square matrix. So if the matrix is not square, then it doesn't have a determinant. Okay. So let's talk about the determinant of 2 by 2 matrices. Alright. So the determinant of a 2 by 2 matrix. Yeah. So suppose I have matrix A. This is matrix A, B, C, D. Right? So if A is this matrix A, B, C, D, then the determinant of A, which is, so for determinant we use this symbol A, B, C, D. So matrices uses square brackets. Determinants use vertical lines like absolute value. So this is equal to AB minus BC. Right? So determinant of A is absolute value of ABCD is AD minus BC. All right. So which one is matrix? The one with the square brackets. And which one is determinant? It's the one with the absolute value. So this is, maybe I should write a note. Note. Matrix uses this symbol, while determinant uses this symbol. Right? Okay. Now let's do an example. So determinant uses just the vertical lines. So it's this diagonal AD minus the other diagonal BC. Right? AD minus BC. So this is diagonal minus the other diagonal. All right. So, for example, evaluate the determinant. Each determinant. So, were you going to send this previously? No? Were you done with it? Yeah? Oh, okay. Okay, so for example, if I have 1, 2, 7, negative 3. So this is the determinant. But if I have 3, negative 5, 8, negative 3. Alright, so what is this? AD minus BC. So what is AD here? 1 times negative 3. What is 1 times negative 3? Negative 3 minus BC. What is BC? 14. Yes, so this is negative 17. So it's a number. Determinant is a number. How about the next one? AD is negative 6 minus BC is negative 40. So what is negative 6 minus negative 40? Negative 6 plus 40 is 34. Yes. So this is still negative, okay? And it doesn't matter if the product of BC is positive or negative, but it is AD minus BC. Yes? Okay, easy? Now, let's talk about determinant for a 3 by 3 matrix. So B, determinant of 3 by 3 matrices. Alright. So I am going to use two methods. The first one is using minor and cofactor. So B1 using minor and cofactor. All right. So let's see. So what is a minor? So the minor of a matrix of how do I say that? Okay. So why don't I not? Why don't I don't understand? Yeah, because it's a little bit complicated. So suppose you have these matrix A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay. So this is a determinant of 3 by 3. A1, B1, C1, B2, B2, C2. So A1, A2, A3, B1, B2, B3, C1, C2, C3. Right? Okay. So anyway, I'm going to use the first row expansion. So I'm going to use the first row expansion here. And related to this matrix is there is a checkerboard sign. So the checkerboard signs always start with positive. So positive followed by negative, positive. So the first row, first column is always positive. And then the next one is what? Negative, positive, negative, and then positive, negative, positive. So this is my checkerboard sign related to this matrix. So I'm going to do the first row. So first row, I'm going to write this first row expansion. All right, so for my signs, what is my sign for the first row? Positive, negative, positive. So plus, minus, plus. Right? Okay. So I'm looking at this sign right here. This is the sign for the first row. And later on, you can use any row. or any column. It's just that what we're doing now is first row. Yeah, can you use second row? Yes, but what we're doing here now is first row. Can you use third row? Yes. First column? Yes. Second column? Yes. Yeah, etc. Now, I'm going to write down A1, because A1 is an element on the first row, followed by B1, followed by C1. So those are my elements on the first row. So first of all, I start with the sign. The second one, we put in the elements. And then the third one, we're going to multiply these by the minor. Okay. So, all right. Can you guys pay attention what I'm doing here? Yeah. So when I'm talking about A1, and I want to know the minor of A1, I will delete the first row, first column, and first row. So the minor of A1 is what? What am I left with? B2, B3, C2, C3. So this is B2, B3, C2, C3. Did you see what I did again? So if I'm talking about first row, first column, I am going to eliminate first row and first column. And when I eliminate first row and first column, what am I left with? B2, B3, C2, C3. Okay. Now, I'm talking about B1. So let me erase this one then. Okay. B1, where is B1? Here? Okay, so which row do I eliminate? First row. So this is B1, so I eliminate first row. How about the column? Second column, right? So what am I left with? What am I left with? What is the minor of B1? A2, A3, C2, C3. So that's what I'm going to write. A2, A3, C2, C3. Right? Okay. So A2, A3, C2, C3. Now, I'm talking about C1 now. Oh, that's sorry. Oh, okay, I have to erase everything now. So this is A1, B1, B2. Okay. Now C1, which row do I eliminate? First row. And which column? Third column. So if I eliminate first row and third column, so let me do this again. Eliminate first row and third column, what am I left with? A2, A3, B2, B3. A2, A3, B2, B3. Right? Okay, let me make it bigger. I don't think you can see. Can we do it again? So let's start. Okay, what do we start with? With the signs, right? So sign is plus, minus, plus. Then we are going to do first column expansion. So where is first column expansion? A1, B1, C1. Am I right? Okay, and now let's talk about the minor. Oh, it's cold? Yeah, today is pretty cold. Okay. So what is the minor of A1? So when I'm talking about A1, A1 is here. I'm going to eliminate first row, first column. So I'm left with B2, B3, C2, C3. So this is the minor of A1. Okay. Now I'm done with A1. I'm talking about B1 now. So for B1, B1's here, I still eliminate row 1 and second column. So I'm left with A2, A3, C2, C3. Are we okay? Now I'm talking about C1. C1 is here. I still eliminate the first row and the third column. So I'm left with A2, A3, B2, B3. Does that make sense? Now this is determinant. Of course, we could calculate each one of them. Yeah, and this is called first row extension, and this part, this is called minor of A1. This whole thing is called minor of B1. Did I say to B1? This is minor of C1. So that determinant part is called the minor. The determinant after you eliminate the row and the column, this is called the minor. All right. Well, it's not this hard because we have numbers. This is a generalization. That's why we have A1, B, A, B, and C. But practically, we actually have numbers. Yeah. Okay. So let's continue. Yeah. All right. Should we do an example? Okay. So let's do an example. Evaluate. All right. Let me see. All right. Let me see. Yeah. So example. What about if I have evaluate? This is a 3 by 3. We evaluate 2, -1, -1. Okay. 1, 2, 0. 3, 4, -3. All right. So this is a 3 by 3 matrix. So maybe let me move this a little bit so we have space. All right, so what do you do here? Do you want to use the first row extension or second row extension, or why do I say second row extension? Because this one contains 0 here. Whenever we have 0, it's always easier to either do the expansion on whatever row or whatever column that contains 0. Yeah. So you know why? Well, because if I have here is a 0, then 0 multiplied by any number. What is 0 multiplied by any number? Is 0. That's why we want to choose the column or the row that contains 0. So should we do second row expansion? Okay, so let's do that to make it easy. So I'm going to write, we are going to use second row expansion. And you know why? Because second row contains 0. Yes, and it makes it easier. Or we could do row 3 expansion. Because this contains 0, makes it a lot easier. Now, then my sign, my checkerboard sign, I have to use the one for the second row. So which one is it? Yes. So I need to start with negative, followed by positive, follow again by negative. All right. Yes, that's the signs for my second row. Now, I'm going to write down the entries on the second row, all the elements of the second row, which are, what are they? 1, 2, okay, 1, 2, 0. Those are the entries on the second row, right? Okay. Now, I am going to write the minor for each item. So for 1, look at this. This is a little bit different. 1 is here. So which row do I cross? This row. And which column? This column. Okay. So I'm left with what? -1, 4, -1, -3. Are we okay so far? All right. Okay. Now, let's look at 2. So 2 is here. Okay. So I am going to cross the second row and second column. So I'm left with 2, 3, -1, -3. 2, 3, -1, -3. Okay, for 0, do I need it? No, why not? 0 multiplied by any number, this will be 0 anyway. So no matter what we have here, 0 multiplied by a number will be 0. So we don't need it, right? Okay, that's how we save our time. All right, so now let's calculate. This is easy. So what is this? This is -1, and then you say, oh, I know the determinant of 2 by 2. This is a 2 by 2. So AD minus BC. So what is this? -3. -3? No. -3 minus -4. What is minus -4? Plus 4. Okay? So this comes from -3 minus -4. So this is actually -3 minus -4. That's why it is -3 plus 4. Right? Do you remember the previous one? The 2 by, oh, here. -6 minus AD minus BC. Now the second one here, what is this? 2 times AD, what's AD? -6 minus BC plus 3. Yes. Yes, Melissa? Which one? I'm sorry. Oh, determinant on the first one? This one? Hold on. So it's, okay, so I didn't copy these correctly. Oh, okay, so I didn't copy this correctly. This is supposed to be what, -3? Okay, what about this? Did I copy this correctly? Yeah, you're right. So this one is not -3. Oh, I'm glad you told me. Thank you. So this is supposed to be 3, right? 3 plus 4. Okay, see, I was thinking about lunch. That's why I made the mistake. So, so luckily you were not, right? So yes. So this is what I was doing. I was doing wrong here. I forgot to put the negative here. So when we are crossing the 1, yeah, you're right. You have -1, 4, -1, -3. Yes. Thank you. Good. Yeah. Did anybody else notice it, or is it only Melissa? You were thinking about lunch too? So okay, same then. Okay. Okay. All right. So what are you gonna have for lunch? Yeah, I don't know either. Okay. So let's continue. Oh. All right. So thank you. Yeah, something like this you have to tell me right away. Otherwise, we did all this work and then it's wrong. Yeah. All right. Good. So what is this? This is -1 times 7, right? plus 2 times negative 3. Okay. Am I still thinking about lunch? All right. So what is this? Negative 7 plus negative 6, which is negative 13. All right. Yes? Doable? Yeah. So I was just doing it really slowly, but actually it's not that slow. Yeah? Okay, it's actually not that slow. All right. Okay. Yeah. Yes, this is multiplication. Negative 1 times negative 3. So it is AD minus BC, right? So this diagonal we multiply. Negative 1 times negative 3. So that's your AD. AD is A times D. So negative 1 times negative 3 is positive 3. Minus BC. What is BC? Negative 4, right? So actually this is negative 1 times negative 3 minus BC. BC is negative 1 times 4. So when you multiply AD, this is 3 minus negative 4, which is what? 3 plus 4, which is 7. Yes, it's always going to be minus. So this is always minus. And then if this is negative, then this is 3 plus 4. So this one is always minus no matter what. Yeah, and then if you have a negative number here, then it's plus. That's why this is plus. Because the next number is negative. Yeah? Okay, good. So far so good? All right. I'm sorry? Oh, negative 13, this is the determinant of this matrix. This is the determinant of the matrix, of the whole matrix. Yeah. So the determinant of each matrix is unique. So this matrix only has one determinant, which is only has one number, which is negative 13. That's all. Yes. So let's do it. You want to do it first row? So let's do it. So let's do that using first row expansion. Good. You're curious, right? So that's good. So I'm going to do this using first row expansion, or actually which one? Third column expansion. Do you want to do third column? Yeah? Okay. Why do you want to do third column? Huh? It has a 0? Yes. So third column expansion. All right. So third column expansion. Okay, so let me write down again 2, 1, 3, negative 1, 2, 4. So I'm not going to think about lunch right now, but I'm going to think about dinner, right? Okay. All right, so let's see. First of all, we're going to talk about the third column. So this is the third column, negative 1, 0, 3. Which one is my sign for the third column? This one? Yes. So that's my sign for the third column. All right. So positive, negative, positive. All right. Now I'm going to write down the elements of the third column, which is negative 1, 0. Oh, thank God for 0, right? 3. Yes. Oh, see, I forgot to do it again. See, I was really thinking about dinner. Okay, so this is plus negative 3. Yes. So this is plus negative 3. Thank you. All right. Yeah. Now, let's write down the determinant for each. For 0, do I need it? No. 0 multiplied by any number will be 0. Yeah. So for the second one here, I don't do. I could write it and then leave it blank. It doesn't matter. So let's look at negative 1. If I'm looking at negative 1, this one, which row do I cross? the first row, and then the third column. So what am I left with? 1, 3, 2, 4. Yes. 1, 3, 2, 4. Are we okay so far? Okay. And then now for 0, do I need? No, I don't. How about for -3? What is this? Yes. So 2, 1, -1, 2. So 2, 1, -1, 6. Okay. Okay. Can I clarify anything before you move on? Because these are just numbers. So if you don't understand where to get it, it's no use to copy. These are just numbers. Does everybody know how I get these 1, 3, 2, 4 numbers? And then how do I get 2, 1, -1, 2? These are just numbers. So if you copy without understanding this, it's no use. Yeah. Okay. So now continue. This is -1 times the determinant, which is what? AD is 4 minus BC is 6. And then the 0 is still 0, so I could ignore the 0. Oh, actually, this is -3. Minus 3. At the 0, I just ignore my 0. It doesn't change the value. Now, AD, what is AD? 4 minus BC, what is BC? -1. What is 4 minus -1? Plus 1. So it's supposed to be minus -1. Yeah. So this is -1 times -2 minus 3 times 5. So what is this? 3 minus, oh no, 2 minus 15. Yeah, which is -13. Yes. So you see it's the same number. Yeah. It doesn't matter what row or what column expansion we use, as long as we do it correctly, and then we're not thinking about lunch or dinner, then you have the same answer. Yay? Doable? Oh, okay. You like it? Okay. Now, should we do another method? Yes. Oh, the cofactor is actually just the sign, this sign, the minus, and multiplied by the minor. So the cofactor is the sign here, the plus or the minus, multiplied by the cofactor. So if I ask you what is cofactor of A1, is the exact same thing, B2, B3, C2, C3. Okay, why? Because this is plus. Now, if you're being asked what is cofactor of B1, then the sign is what for B1? Negative. So it's going to be minus of A2, A3, C2, C3. So cofactor is just the minor multiplied by the checkerboard sign. Yeah, so it depends on the location of the element. Does that make sense? So this is the checkerboard sign. So actually here there is a plus, but we usually don't write the plus. Yeah, but it's just the minor multiplied by the checkerboard sign. That's the cofactor. Can you tell me what is the cofactor of C1? What is the cofactor of C1? Is it plus or minus? Plus. Plus, and then the determinant of A2, A3, B2, B3. Make sense? Okay. All right. Now, should we do the other method, or you guys like this? Okay. So we don't have to do the other method? No? Okay, just do one is good enough. Now, why do I teach this one first? Because you can use this for a 3x3 or 4x4 or a 5x5. Of course, they're more complicated, right? But you could you could do those for the other ones also, not just for 3 by 3. The other method, if I were going to teach it, it's only for 3 by 3. So it's limited. Yeah, not that I'm going to ask you to do 4 by 4 or 5 by 5, but it's good to know that these can be applied to 4 by 4, 5 by 5, etc. Well, let's continue about Cramer's rule. Why do we use this? So let's talk about Cramer's rule. Let's see. C. So this is why we calculate determinant. One, your calculator can easily calculate for you. Well, your graphing calculator, not your scientific calculator. So that's why people use that. So Cramer's rule for 2 by 2 system. All right. When I say 2 by 2 system, what do I mean? 2 rows, 2 columns. Actually, it means, well, if it is for matrix, that's right. This is for systems, 2 equations, 2 variables, right? Yeah. Yay. But for matrix, you're completely correct. It is 2 rows, 2 columns. Okay. So this is what Cramer found out. So he did research for years and years and years, and this is what he found out. So the solution of, okay, right here, A1x plus B1y is equal to C1, and then A2x plus B2y is equal to C2. So this is a 2 by 2. And of course, in the beginning, we will start with A, B, and C. Yeah. Is given by x is equal to d sub x over d. Y is equal to d sub y over d. So I haven't written down what d sub x, d sub y, so I'm going to do it now. So d, this is the determinant of the coefficient of x and y. So, what are the coefficients of x and y? A1, A2, B1, B2. So that's your d. Of course, later on you'll have numbers. Right? So d is determinant of the coefficients of x and y. All right. What about d sub x? This is read as d sub x. So d sub x, all right. Which one is the coefficient of x? A1, A2. We will replace that by the right-hand side. My right-hand side is C1, C2. So this one is C1, C2, B1, B2. So replace coefficient of x by, I'm just going to say the elements on the right-hand side, so I'm just going to say right-hand side, right, the right-hand side. Yeah. So this is your coefficient of x, but I have to replace it with my right-hand side. Yeah. No, no. So you're not changing the order. Yeah. So the x we just replace with C1, C2. So it moves here. Yeah, as the first column. And this is read as d sub x. Good question. Now, if we apply the same thing to d sub y, can you tell me what it is? So what do we do to get d sub y? Replace coefficient of which one this time? Y by the thing on the right, by the right hand side. Okay? So I'm going to write this one first, C1, C2. Because this is what I replaced. This is the coefficient of y, which I replaced. How about the first column? Well, it's still A1, A2. Because those still contains the x, the coefficient of x. Alright. Yes? So basically, what's the difference between d and d sub x? Well, for d sub x, we replace the x. What about d sub y? Well, for d sub y, we replace the coefficients of y. That's it. Yeah. Well, how did Kramer find these? Well, it took him years. Yeah. Okay, so let's do an example, and then I don't know how he got to find these. Aren't you amazed also? Some people want to spend their time thinking about a problem and then finding the solution, right? Okay. All right. What about if I have solved using Kramer's rule? Well, can we use elimination substitution? Of course. This is just another way of solving it. Yeah, of course, you could use elimination substitution. Why not? And usually we will use elimination substitution because it is shorter. Right? 4x plus 3y equals 14. Alright, so this is equation 1, this is equation 4. Can we solve this using substitution? Yes. And then actually elimination here you could just add, right? Okay, let's do using Kramer's rule. Yeah. I know we could just add, but let's do using Kramer's rule. Okay, so what do you think you'll do? Well, I am going to calculate d. Okay. What is d in this case? 8, 4, negative 3, positive 3. You're right. You're totally right. Now, let's do d sub x first. What is d sub x here? And then you say, oh yeah, I have to substitute which one? I have to, the x, 10, 14. But the y's don't change, so I'm still going to use negative 3 and 3 for the coefficients of y's. And then d sub y. Yeah, so which one do I change? The y, so this is 10, 14. So this is the ones that I change. So how about the x? Stay the same. 8. Okay, now we just have to calculate AD minus BC. AD, 24, minus BC, negative 12. So 24 plus 12, 32. Same thing, AD, 30, minus BC, oh, is it negative 42? So this is 72. And then last one, AD is 8 times 14. Is it 112? Yeah. Minus 40. So this is 72 also? Okay. All right. So we calculated all the determinants. So let's calculate x. What is x? D sub x over d, which is 72 over 36, which is 2. What is y? I think y is the same value. D sub, not d sub x, d sub y over d, which is, d sub y is 72 divided by 36, which is 2. So what's your solution? 2.6. But this method is a little bit longer than the addition or elimination or substitution, right? So we usually don't use this. Yeah, but we have to know, right? We want to use Cramer's rule also. Yeah, is it easy? Yeah, that's right. Yes. Should we do the 3 by 3 now? Cramer's rule for 3 by 3? Yes. 2 by 2 is simple, right? Okay. So 3 by 3 system. What time are we done? 15 minutes? Yeah, we can do one example. 3 by 3. So try the Cramer's rule. I know it's longer and we usually don't do it. However, when you're doing the homework, try using the Cramer's rule for this section. Yeah, so this is from which section? 8.7. Yes. So that is the last section I'm going to discuss from chapter 8. Yeah, okay. So now, what happens? Next page. B. Cramer's rule for 3 by 3 system. All right. So it's going to be the same idea. I don't think I could use A, B, C, D. Oh yeah, I could use A, B, C, D. Yes. A1, D1, C1, D1. Yes. What does 3 by 3 system mean? There you go. So you'll have X, Y, and Z. Same thing here for Cramer's rule. It's just that you have a Z, which is D sub Z over D. So the solution of, and then you have a 3 by 3 system. All right. A1x plus B1y plus C1z is equal to D1. So notice that you have one more variable, ABC, and then D. A2x plus B2y plus C2z is equal to D2. What do you think the last equation will be? A what? 3x plus B3y plus, right, equals, perfect. All right, is given by same thing. So I'm going to write the same thing. X is equal to D sub x over D. Y is equal to D sub y over D. Z is equal to D sub z over D. Okay, where? Okay, tell me what D is. D is the coefficients, isn't it? Okay. So what do you think D will be? A1, A2, A3. Alright. The next one, the next column will be B1, B2, B3. The next column will be C1, C2, C3. Then that is your D. Okay. Pretty similar. Now, D sub x. What is D sub x? Then you remember, oh, for 2 by 2, if I have d sub x, what do I do? Replace x by right hand side. So I'm still going to do the same thing here. So this is read as d sub x. So I'm still going to do the same thing here. So this part, this is my x, I will replace with the right hand side, which is d1, d2, d3. So this is d1, d2, d3. But this time it's x that is being replaced. So, well, the other ones, which is the y and the z, so I'm just going to copy this, d1, d2, d3, d1, d2, d3. All right. Now, I think you could guess d sub y, right? Which one am I going to replace? The y? Y is in the middle. So this one, replace y by right hand side. And y is in the middle, so I'm going to put d1, d2, d3 in the middle to replace y, coefficients of y. And what about these? A1, A2, A3, C1, C2, C3. Almost done. D sub z. And then I remember, oh, this is dz, or this is dy, this is dz, d sub z. So we're replacing which one? Yeah, the last one. So we're replacing this part here. I'm going to put all the d's in first. D1, D2, D3. And then this is A1. And this is D. So replace coefficient of Z by right hand side. Are we okay so far? Easy? It's easy, but you need to get used to it, right? You need to remember. Okay, can we do one problem? We probably won't be able to finish it, but we'll do one. How about that? Because you have to calculate. Then on the exam, I'll ask you to calculate d sub x, d sub y, and then the z will just do substitution because it's long. Yeah. Or let's put the one with a lot of zeros. Let me see. Oh yeah, let me put a lot. Then it's inconsistent, right? Or identity. All right. So do an example. No solution. Oh, we will talk about no solution and infinitely many solutions tomorrow. Yeah. How about this? If I have 4x plus 2z is negative 7, and then 8x minus 2y is negative 7 also, and then 10y minus 2z is negative 5. All right, here. So 4x plus 2z is negative. Oh, I'm sorry, this is not negative 7. The first one is 7. So this is 7, okay, not negative 7. So 4x plus 2z equals to 7. I don't know, what did I write here? Let me check. It's number 56 from the book. 8x minus 2y is negative 7. Okay, give me a second. Okay, I need to check because otherwise we did this and then it doesn't work. It is frustrating, isn't it? Okay, let's see. This is chapter 8. It's number 56 in the book. Oh, I don't have it here. It's probably from a different book. Oh, no. Okay, 4x plus 2z is 7. 8x minus 2y is negative 7. 10y minus 2z is negative. Okay, so how do we set it up? What is d? 4, 8, 0. 0, negative 2, 10. And then 2, 1, negative 2. All right. Oh, good. So I thought you were sleeping. No, you're not. You're completely awake. Right? Okay. So this is 0. 2, 0, negative 2. Good. Now, what about d sub x? And then I remember, oh, d sub x, the x I have to change. So what am I supposed to write here? 7, negative 7, negative 5. Yes. And then the other one is the same thing. The y is 0, negative 2, 10. The z is 2, 0, 3. All right. And then d sub y? So we will just do d and d sub x today. What is d sub y? For the y, we will change. So this is 7, negative 7, negative 5. And then the x is 4, 8, 0, 2, 0, negative 2. And then d sub z. Do we have to calculate all of them? Well, no, but I'm just setting it up for you. 7, negative 7, negative 5. And then 4, 8, 0, 0, negative 2, 10. Yes, are we okay so far? Okay, so how do we calculate the d? Oh, my first column has a 0, so let's just use first column extension. First row, I'm sorry. First row, right? Extension. I can actually do first column also, but we're used to first row. Do you remember the signs? So if not, then I could do the sign. So my signs always start with plus. So what is the sign of the first row? Plus, minus, plus? Yes. So plus, minus, plus. Oh, let me get more space. And the numbers? 4, 0, 2. So this 0, I don't have to give more space. It's 0 multiplied by any number here will be 0 anyway. So this one, I could write down the minor, but for 0, I don't need to. It will be 0. So what's the minor of 4? Cross up, cross up. So what is it? Negative 2, 10, 0, negative 2. So I'm crossing out the first row, first column. So I only have negative 2, 10, 0, negative 2. Yes? Now, do I need the minor for 0? No. If I multiply with the minor, it will be 0 anyway. So I'm going to skip this. Let's do the 2. So which one do I cross out? The first row, third column. So if I cross out the first row, third column, then I'm left with 8, 0, negative 2, 10. All right. Yes, do you guys know how I got the numbers? Clear? Okay, so now we just do the calculation. So 4 times negative 4 minus 0. And then this is 0. We can ignore 0. This is 80. Oh, it's minus 0 also. So what is this? Negative 16 plus 160. So 144. Is it? Oh, which one? Oh, so this is positive 16? Yeah, you're right. So it's too many numbers now. So this is positive 16. So 176. All right. Cool. Okay. Do we want to do another one, or you guys want to do it tomorrow? Do the d sub x? Or just set up? Okay, let's do it. Because I think you guys like it, right? Okay. Now, are we going to the first row again? Okay, so first row expansion. Cool. What are my signs? Positive, negative, positive. And the second one here is 0, so 7, 0, 2. So the zeros, I don't have to give more space. It will be 0 anyway. Alright. So now think about what numbers. I cross out 7, first row, first column. Left with negative 2, right? 10, 0, negative 2. Yes. And then next to 0, nothing. And then what about these two? Cross out, so negative 7. You're not sure? Okay. All right, perfect timing. We're finishing this. That's what I said. Yes. All right, 1 more minute. This is almost done. Yeah. So it is 7 times. I'm gonna talk to the machine, right? What is it? Negative 4? No, positive 4, right? Yeah. So positive 4 minus 0, and this is 0. We can just ignore. It will be 0 anyway. Plus 2 times what? Negative 70 minus. So plus 10 then, right? Okay. All right. So what is this? 7 times 4? Oh, it should be negative 10? Yeah. So minus 10. Yes, you're right. So what is this? 28 minus, is it minus? Minus 160. What is 28 minus 160? Negative 1 what? 32? All right. So this is a fraction here, right? Because you have the, so x, we already know what x is. X is negative 132 over 176. Unless we made a mistake. No, we didn't? No, we didn't. Yeah. All right. So can you guys, at home, can you guys finish the D sub Y and D sub C? Yeah, just for practice. So you remember? Yeah. But these are not that hard. It's just that you have to be careful and pay 100% attention, right? Okay. Well, let me call the attendant. Jose, can I talk to you after? Yeah, I'm going to tell you exactly how you're going to do it. Okay. So make sure we finish everything today. Did I call every attendance? No, right? Okay, let me close the recording. Oh, I didn't save the note, did I? Oh, maybe I did. So tomorrow we will still continue with determinants and Kramer's rule. Okay?